Hello, I'm Anya Lichtarowicz, and this is Somewhere on Earth, your weekly look at technology and its impact on our everyday lives. It is Tuesday, the 14th of July, 2026. Welcome to the Global Tech Podcast. Coming up today, what can we learn from the birds that dive beneath the waves and effortlessly take to the skies? This week, we meet the MIT engineers who've built a remarkable new robot that can do just that, swimming underwater before flapping its way back into the air. Inspired by puffins and other diving birds, the technology could transform the way scientists explore our oceans and monitor some of the planet's most remote environments. And as countries look for ways to cut carbon emissions, we turn to the future of home heating. At East Mid's Tech Week, we caught up with Vaillant UK to find out how the latest generation of heat pumps is making low-carbon heating quieter, more efficient and easier to install, and why the company believes innovation will be key to the energy transition. That's Somewhere on Earth, where tech meets humanity. For millions of years, nature has solved engineering problems that humans are only just beginning to understand. Birds like puffins, loons and petrels can effortlessly dive beneath the waves to hunt for food, then burst back into the air and continue flying as if nothing has happened. Now engineers at MIT have built a robot that can do something remarkably similar. The flapping wing aerial-aquatic vehicle weighs less than 300 grams, can swim underwater, launch itself through the surface and fly away, opening up exciting possibilities for ocean science, environmental monitoring, and search missions in places that are difficult or even dangerous for conventional vessels to reach. I spoke to Professor Raphael Zufferey from MIT, who led the research.
We observed that there is over 100 species of diving birds that can sort of seamlessly move between flying and swimming. And in very different ways. So there's very different solutions that that birds have found to move in these two different fluids, right? And so that inspired us to look about how we can take these locomotion approaches and use that for robotics. So that's what this paper is really about. This publication is about. And we looked at these birds and really transform that into how robotics can move in both those fluids.
So nature solved this problem millions of years ago. You've been inspired by puffins and loons, those kinds of birds. Tell me how they taught you to come up with an engineering solution.
Yeah, so the first thing that we looked at is the flapping frequency. So really the amount of strokes per second that wings use when in flight and when swimming. And so this was a very good starting point to know how to design these systems in robotics, right? And then we also observed that diving birds partially fold their wings underwater, which is complicated to reproduce in robotics, right? So that would mean you need to make a wing that has several joints, and these joints need to be able to take the high forces that you get from flapping in the air. So all of this adds complexity. So we took that principle of wing folding, which birds use to reduce the loads on the wings when they're underwater, and used flexibility, so the wing bends instead of reducing through folding to get the same effect.
So I'm assuming that this is to solve that problem, as obviously the densities of water and air are so different, aren't they? And this changing of the shape of the way the wings flap or fold has helped you overcome this.
Yes, that's exactly this, right? So we looked at how birds do it, how they reduce the loads underwater. So if you took your aerial wings and you just try to flap it very quickly underwater, it won't work because the forces on your system is too high, right? So either you will break your motor or you will break the wings themselves, right? And so how birds adapt to these different fluids is what we looked at. And we found that we can get a similar function through wing flexibility in robotics. So we have wings that are vastly more flexible than what birds do, actually. And so that means that underwater you will have a wing that bends a lot. So instead of getting the full amplitude of about 60 degrees that we get in air, we get a vastly reduced amplitude in water, which reduces the loads and therefore allows us to still flap at reasonably high frequency underwater.
And you've also found that your robots don't need feet. The birds use their webbed feet to push off from the surface of the water, don't they? But your robots don't need that extra push.
Yeah, so I mean, until now we really talked about the adaptation between water and air. How do you move in both fluids, right? But one of the big unknowns that we had is it possible for a robot that uses just flapping wings, so there's no propeller on board, is it possible for such a robot to go back to flight from the water? And if you're doing any sort of ocean application, you need to recover these robots, so that is important. And if you look at diving birds, most of them, not all of them, but most of them use their feet to run at the water surface to get into flight. And doing something like this in robotics is challenging because that means adding additional motors, additional joints, additional structures, and therefore we looked at how can we do this without any legs.
You succeeded. How did you do it then?
Yeah, so the key to be able to do this is to have enough power on the robot. So we're able to generate a flapping frequency that is much higher on the robot than what we need in flight. So in flight, you would need typically about 5 to 6 hertz, so 5 or 6 flaps per second to fly horizontally. And to come off the water, we can temporarily increase our flapping frequencies to 10, 11 hertz. And so this gives us a very strong increase in the thrust that we generate on the robot, and therefore allows us to leave the water. We also found that to be able to do this, you need to reach the water surface at a very specific angle, so around 70 degrees. And if your angle is too low, if you're trying to get to the surface and your angle to the water surface is lower than 70 degrees, say maybe 45 degrees, then what happens is the robot will sort of just bounce on the water surface and will not transition to flight, right? And also, if your angle is too steep, so if you're flying out vertically out of the water, then you'll just crash. So the robot will do a very short flight backwards, and you will not be able to recover. So there's this range of angles that we identified in this research that enable successful transitions. There's other aspects that we looked at as well, such as the tail position, the tail size, that is also important in enabling these transitions.
So you've come up with all these amazing solutions that sound as though they belong in a science fiction novel, and you've also had to make the robots waterproof. How did you do that?
Yeah, so typically if you want to build an underwater robot, what you would do is you would get an enclosure. So you would get perhaps like a tube with like 2 caps on the end, right? To make sure that your electronics are waterproof. Now, if you do this, your robot would float because of the air that you trap in that container. So the solution is you would add some mass inside of the tube, so perhaps some steel, and that would make your robot neutrally buoyant, right? Now the problem is if you do this in a system like this, right, it would just simply become too heavy to fly, right? So that's not an option. So you cannot use enclosures if you're trying to build a robot that's neutrally buoyant and still wants to go to flight. So instead, what we did is we individually waterproofed every single component on the robot, every single electronic component. So the battery system, the flight controller, the motor drivers, all of these are individually sealed. And therefore we can maintain neutral buoyancy. So the robot, when it's underwater, neither goes to the surface nor does it sink. And so that's how we solve this problem of waterproofing.
Putting aside the new tech and engineering solutions, these new robots will be able to gather better data from our oceans. Why is this necessary, and how are you going to do it?
Yeah, so most ocean research to this day is done with boats. So scientists go onto a boat, a vessel, a research vessel, which costs usually $20, $50, $100,000 per day. Very expensive operations, involves lots of people, and is also usually polluting. And so the hopes with this technology is that we can get robots that don't require vessels anymore. So you would be on the shore, you could launch these robots into flight, cross a significant distance. We're talking kilometers here, and identify the region of interest, or perhaps you pre-program that robot to go to a certain GPS coordinate. It would then dive into the water and take the measurement that you need in the water at the depth required, right? It would then swim back to the surface and come back back to shore, where you'd recover the robot and repeat the measurement, or you could even imagine in the future some sort of like more automated launch system.
You're thinking about the best place to launch these robots from, so from glaciers, near whale pods, for instance, and in fragile marine ecosystems. Currently, you would collect data from a boat, which obviously disrupts the marine environment. So these new robots could avoid this and really improve our knowledge of the oceans.
Absolutely. So one of the aims of this research was to build robots that are small in scale. So we're talking 1 meter in wingspan, and therefore affordable. So one of these would cost around like $300 to $400 in parts, which is extremely affordable when you compare that to multi-million underwater robots that we currently have in the oceans. And the flapping wings themselves mean that we don't have a fast spinning propeller on board, and so they're very safe. In fact, we routinely catch these robots in flight as humans, and they don't cause any damage. So for underwater studies, we could access environments and not disturb them with this technology.
This research is published in the latest edition of the journal Science. A gentle reminder, dear listener, of rating us. We've had some great reviews and we can see downloads increase as soon as someone gives us a 5-star recommendation. So huge thanks for that. Also, do not forget you can get an extended version of the show with no ads on the pod.fan website. That is just $10 a month. It's only a few weeks since the first ever East Mids Tech Week brought together innovators, entrepreneurs and businesses from across the region to showcase the technologies shaping our future. But such was the success of the inaugural event that planning is already well underway for next year, and tickets will be on sale soon. One of the companies at the heart of this year's event was Vaillant UK. While many people know the company for its boilers, today it's developing the next generation of low-carbon heating technology, including highly efficient heat pumps that could play a key role in reducing emissions from our homes. I caught up with James Fowler, Marketing and Strategy Director at Vaillant UK.
So Vaillant as a company was founded in Remscheid in Germany just over 150 years ago. We are very proud to still be a family-owned company, and we have a long heritage in the Derbyshire area. Our Glowworm brand originated here in the 1930s, so we've been producing heating and hot water products in the UK and in Derbyshire in particular for the last 92 years. And more recently, we've invested into a new production site in Derby.
And you're famous here for boilers, really. That's what I think the general public think about. But obviously technology's moved on a lot, as has the company. So tell me a little bit about the tech that you've been showcasing at East Mids Tech Week.
Okay, so I'd probably say we're more famous for innovation. We've had a long history of producing the next generation of heating and hot water products. We're still proud to have, when we had R&D in the Derbyshire area, produced the smallest ever gas boiler in the UK. But more recently, we're transitioning now to electrified heating, so that's very much more in the heat pump direction. Here in Derbyshire, we produce heat pumps as well as gas boilers. We produce the cylinders that go with a heat pump system. And as an organisation, we're probably leading the way in terms of driving a heat pump adoption in the UK.
Heat pump, tell me how that technology works. I'm sure there'll be quite a few listeners who may have not even heard of that term.
The one thing we will always talk around is people have heat pumps in their home already. So a fridge, and as much as I don't like this comparison, but it is a heat pump, it just works in the opposite direction, so it cools rather than heats. To use a heat pump for heating and hot water is a little bit more complex. you do need an outside unit. Think similar to an air conditioning unit that people are quite familiar with. You do need a hot water cylinder somewhere in the property internally. But ultimately, it's a very, very efficient way of heating domestic properties. With our new generation of products, we have heat pumps which can pretty much go anywhere. So there's all kind of restrictions around siting of older heat pumps. With our latest generation we've been showcasing today, we take away a lot of those barriers. We also make it slightly quieter, slightly more efficient. And the real drive for heat pumps is the efficiency, that you're generally looking at a 3 or 4 times efficiency to a traditional fossil fuel boiler. Cost-wise, if you're on gas, that might be a break-even point, but if you're on an oil heating technology, there can be significant cost savings as well.
So you're saving costs, less environmental impact, and this is very much a technology that the UK government is pushing for.
It is a technology that the government is pushing for. I think if you look at governments around the world, this isn't a UK thing. This over-reliance on fossil fuels, this drive for decarbonisation, this drive to reduce carbon emissions everywhere is a global problem. It's not a UK problem. I think particularly in Europe we see lots of markets adapting similar approaches to how they drive adoption. And of course the government here in the UK has put incentives in place to encourage homeowners to adopt a new technology.
Tell me a little bit about the technology, because I don't think I really understand it, to be honest with you.
So the way a heat pump really works is it pulls through air from outside, it compresses a refrigerant, and that compression process generates the heat that then heats up the hot water. So you have a kind of heat transfer from the compression through to the water system in a very simple nutshell. Beyond that, it works in the same way as a traditional heating system. So you have heated water that you pipe around your property through the pipework, through radiators. You have the hot water cylinder so that we can, again, divert the energy to heat the hot water there. And that's how we pull off for your showers, your baths or your taps.
And where does the technology help with all these efficiencies that are coming in, that are making it better for the environment and it cheaper?
So if you look at a fossil fuel, if you burn gas to heat, there's a built-in kind of physical limitation to how much efficiency you can get. When you take heat from the air or from the ground with a ground source heat pump, use different refrigerants with different efficiencies, different global warming potentials, you can start to really drive efficiency of heat transfer, which is how you get a 3-to-1 or 4-to-1 efficiency gain.
And you're a champion partner, so you've been supporting East Midlands Tech Week along their journey to their first ever event. Why did the company decide to back this?
So we backed this probably for 2 reasons. First of all, East Midlands Tech Week is hosted in Derby in Vaillant Live, which is a venue that we're very proud to sponsor, and it's a sign of the investment and the redevelopment within the city that we're very proud to be part of. And the other reason is we are a tech business in the East Midlands, so we may not be as far down some of the AI or digital routes, but we bring high quality skilled work to the Derby area, and we're very proud of our heritage. Like I said earlier, we've been in the region for 90 years producing heating and hot water. When you look at the theme today around construction and where we've been involved in the event, we're bang at the heart of that in terms of how we regenerate the city, regenerate the UK, and our technology can play a part in that, and the industry we're in will play a part in that, even if it's not us specifically.
And you are a global company, so that those changes in that technology will be seen much further afield.
Oh, yeah, of course. So we operate in most continents around the world. So we're very strong in Europe, but we're also into Asia. We have global manufacturing, we have global supply chains. We have a very strong focus on our impact on not only the local environments, but also that global scenario as well.
James Fowler from Vaillant UK, a champion partner at East Mids Tech Week 2026. Details of how to get involved with EMTW in April 2027 are on their website. And that's all for this edition of Somewhere on Earth, the Global Tech Podcast. I'm Ania Lichtarowicz. Until next week.